So now we're going to get into how do we name ionic compounds based on their formulas. And that's the reverse of what we just did in the previous video. But sometimes it can be a bit more complicated because of certain things we're going to discuss later on. All right. So let me make this larger and get into naming ionic compounds that are binary, right? So let me go back to this slide here. So we're talking about, in this particular section, we're talking about binary ionic compounds. And what do we mean by binary ionic compounds? Basically, binary ionic compounds are compounds that contains two elements, two different elements only, right? Now, we talked about binary molecular compounds where the two elements are nonmetals. In the case of binary ionic compounds, they are made up of one element, which is a metal, and the other one is a nonmetal, all right? So that's what we mean by binary ionic compounds. And the rules we're going to discuss here is basically dealing with how do we name them, all right? Now, we're going to divide this discussion into two sections. One section where we're talking about binary ionic compounds where the metal can form only one type of cations, and then the next section we'll talk about naming ionic compounds, binary ionic compounds, where the metal can form more than one type of cations, all right? So that's a bit more complicated, and we're going to take some time discussing that. But for now, we're dealing with the situation where the metal that is involved can only form one type of cation, right? So this is basically how we go about naming these compounds. Basically, we take the name of the metal first. That is basically what starts off the name of the compound, and then we follow that by the name of the nonmetal, which is modified to include the ending IDE, as we discussed in the previous video when it comes to naming anions, all right? Now, another thing I need to mention here, and this is one big difference between naming binary molecular compounds and binary ionic compounds. We do not express the number of atoms present in the formulas, right? So we do not use, prefixes like mono, di, tri, etc., right? That is not allowed when it comes to naming ionic compounds. Okay, so that is something you need to keep in mind as well. So to summarize, basically this is what we do in order to name binary ionic compounds. We start off with the name of the metal, then the stem of the name of the nonmetal, and then it ends with IDE, all right? So this is basically a summary of how we go about naming binary ionic compounds. Okay, so let's look at this example. Let's say you're given this formula, CaF2, and you're asked to name it, right? Now you should immediately recognize that this is a binary ionic compound because there are only two elements present. One is a metal, the other one is a nonmetal, right? So basically, the next step is to identify the ions involved. One of them would be the calcium ion, which has a +2 charge, right? So the first part of the name of this particular compound would be calcium, and then the other part would be consisting of the fluorine ion, or I should say the fluoride ion. So therefore, the name of the element is fluorine, but of course we have to modify it by adding the IDE ending to the stem of the name. So we start off with fluor and then it ends with ID. So the name of this particular ion is called the fluoride ion, right? And then we just simply put the two together and the answer becomes calcium fluoride. And that's basically how we name these compounds, all right? Okay, so just to give you some examples of binary ionic compounds according to the rules that we have just learned, how we name them. So NaCl, the name of this compound is sodium chloride, right? We have the name of the metal, which is a sodium, and then the name of the nonmetal stem, and then it ends with IDE, all right? And that's basically how we do that. Same rule applies in this case, magnesium chloride. Magnesium is the first part, which is the name of the metal, and then the chlor would be the stem of the nonmetal name, and then IDE, all right? Another example here, K2O, the name of the metal first, which is potassium, followed by the stem of the name of the nonmetal, which is oxygen, so we use ox as a stem, and then it ends with IDE. Here's another one, Na3P, the name of the metal first, which is sodium, then the stem of the name of the nonmetallic element, which is the phos part of the name, and then the stem, or I should say the suffix, the ending is IDE. All right, so that's basically how we name binary ionic compounds of one type. We're going to talk about the other type shortly. But just to give you a list, a short list of different elements that are nonmetals and their stem and the resulting anion names derived from the stem. This is a list right here. So this is something that you need to simply know. And it's kind of easy to memorize if you just if you just follow the rule, right? Basically, it's the stem of the name of the element, the non-metallic element, followed by IDE. That's basically it, all right? Okay, so that's as far as naming binary ionic compounds. Well, not quite. We have one more list right here. And these are just examples of binary ionic compounds. As you can see, all of them ends with IDE. They are binary because they're made up of two elements. They are ionic because one element is a metal, the other element is a nonmetal. And basically, we just follow the rules, and that's how we derive the names based on their formulas. Okay, so the next section, we're going to start in the next video. So I'm going to stop this right here, and then the next discussion we're going to talk about is how do we name binary ionic compounds where you have a metal that can form more than one type of ion. All right? Until next time.